Hi, today we're going to prove that the opposite sides of a parallelogram are congruent. And if we look, we see the theorem there and our given information. Today I'm going to show you how we're going to write a proof, kind of a two-column proof for it. So the first thing I need to note is that I have added a diagonal there. That is dB. And we know that dB is congruent to dB by that reflexive property, which says something is congruent to itself. Now, I also have some other information that's given to me by the tick marks. I know that AB is congruent to CD, and AD is congruent to CB. And all this information is given to me. Now I can see that I have two different triangles in this quadrilateral, and I know my triangle congruence tells me that I can say they are congruent by side, side, side. Triangle congruence. So I'm going to go ahead and write that down, that I know that triangle ABD is congruent to triangle CBD by side, side, side triangle congruence. I know that because these are congruent, I can say that the angles are congruent where I bisected my quadrilateral. So, angle ABD has to be congruent to angle CDB. And angle ADB is congruent to angle CBD. And this is by our favorite corresponding parts of congruent. Triangles are congruent. Now I can apply the alternate interior angles property to prove that the opposite sides are parallel to one another. So using that property, I see that AB is parallel to DC, and AD is parallel to BC. And this is by what we call the converse of alternate interior angles. So now I've shown that the opposite sides of the parallelogram are congruent, so therefore I've met all the criteria to say A, B, C, D is a parallelogram. I hope this helps you as you are working on proving the opposite side criterion for a parallelogram.